It's a beautiful sunny launch day here at the European Spaceport in French Guiana. Welcome to our YouTube Live Road to Space. We are transporting a South Korean satellite today, KOMPSAT-7. 안녕하세요. Hello, South Korea. Great to have you with us. KOMPSAT-7 is flying on board a Vega C rocket. It's tucked up safely inside that fairing at the very top of the rocket. And we are about 15 kilometers from that pad in the Mission Control Center, very much the nerve center of operations. You can see the teams there behind what we call fishbowl, the glass, the protective glass. I'm Katie Haswell, and joining me here in the commentary box is our expert, our rocket expert from Arirang, Vincent Baudin. Thanks for being with us, Vincent.
Hi, Katie. Great to be here.
How are things looking for the launch?
Absolutely, sorry. So all systems are green, and we are ready for liftoff.
Okay, that's scheduled in 9 minutes' time. What's going to happen after that?
Yes, the launcher lifts towards the north, powered by 3 solid propellant stages, each one separating after finishing its job. The fairing is jettisoned once the launcher leaves the atmosphere, and after the Airborne upper stage is then ignited for 10 minutes, putting the launcher in an intermediate orbit. After a coast phase over the North Pole and down to East Asia, the Airborne ignites its engine again to reach the final targeted orbit, and the spacecraft is then separated from the launcher. The upper stage enters a new coast phase before a third boost to re-enter the atmosphere over the Indian Ocean.
Indeed, a lot to look forward to there coming up in the next 50 minutes or so. Now, we are launching KOMPSAT-7 for the Korea Aerospace Research Institute, KARI. Let's find out more about our satellite.
AEISS-HR Advanced Air Image Sensor System with High Resolution, которая обладает разрешением в 30 сантиметров в панхроматическом режиме и 1,2 метра в цветном режиме и 4 метра в инфракрасном режиме. Отделение аппарата примерно через 45 минут после запуска. Производитель Korea Aerospace Industries. Оператор Корейское космическое управление. Запуск на Солнечной синхронной орбите. Вес аппарата 1800 килограмм. Это будет 28-й запуск ракеты Vega, третий в этом году и 305-й запуск ЕСА в истории и 6-й запуск ЕСА в этом году.
In an era when understanding our planet has never been more vital, KOMPSAT-7 will deliver high-resolution images to the Korean government as the primary user, as well as to civil and global partners to support international cooperation. Once in orbit, it will support geographic information system applications, along with environmental, agriculture, and ocean monitoring. It will also help track natural disasters by detecting forest fires, volcanic activity, waste heat pollution in lakes and rivers, flood damage, and urban heat islands. The impact of this mission will turn pixels into insight and insight into action. With fire and precision, Vega C will propel KOMPSAT-7 into space, a statement that accuracy and innovation can orbit together.
And the job of preparing the rocket and the spacecraft here at the spaceport actually started a couple of months ago. We call that process the launch campaign.
Yes, so actually we can prepare several different launches, so at the same time here at the base, so it's very great for our customers.
It really is. And our cameras have been following the KOMPSAT-7 launch campaign as the teams have been preparing for today. There have been quite a lot of activities over that time. What's been happening?
So the launch campaign starts with the preparation of the launcher, with first the P120 booster installed on the launch pad. Then we transfer the second stage, the P140, to the launch zone where it was tilted and lifted inside the mobile gantry and finally integrated on top of the first stage. We followed the same logic with the third stage, the P9, transferred to the launch zone. It's lifting inside the mobile gantry and integration on top of the second stage. And finally, the Airborne Plus upper stage arrived in its container by road. It was lifted on the upper platform and mated on top of the third stage. In the meantime, the KOMPSAT-7 spacecraft arrived by plane in French Guiana. It was prepared and fueled in the CG clean rooms and finally mated on its adapter and encapsulated inside the fairing. Once completed, the payload assembly composite was transferred to the launch zone by night. It was lifted inside the mobile gantry up to the upper platform, where it was finally prepared and integrated on top of the launcher. The ventilation inside the fairing was then adjusted in order to ensure the best condition for the spacecraft. And after that, final checks and verification performed during the last day. The mobile gantry was removed today, 4 hours ago, and we are fully ready now for the liftoff.
Indeed we are, here in the final phase now, coming up to the final phase of the final countdown, coming up to the beginning of the synchronized sequence, the automatic sequence. That's the last 4 minutes.
Yes, Kitty. So during this time, the rocket will become progressively autonomous, so computers will manage a complex sequence of operations.
Attention pour la séquence finale lanceur.
Xavier Nero getting ready to call that out.
Top H0, moins 4 minutes.
Vega C представляет собой несколько ключевых усовершенствований по сравнению с современной ракетой Vega. Первая ступень заменена более мощной P-120 и указывает на общую конструкцию, позволяющую использовать ее в качестве ускорения для ракеты-носителя Arirang-6. То есть Arirang-6 это вот
Now,
тот же
we
самый
have a number of control
ускоритель
rooms
Arirang-6,
on the
это
job
тот же самый
today. We've been focusing a lot so
что и
far
тут на
on
первой ступени.
mission
Понятное дело,
control and the
только
teams
кроме
here.
отделителя
We
для
have
второй
another
ступени там
control room
устанавливается
called
вот
launch
аэродинамический
control,
обтекатель.
and the teams
Это
there
позволяет
are very
разделить
much
затраты на разработку. Вторая
dealing
ступень
with
оснащена
everything to
модернизированным
do with
двигателем
the
Zephyr 40,
rocket
проблема четвертая
and the
ступень
pad,
Apple+.
and very much
То есть
pre-launch, isn't it,
аттитут и
Vincent?
Вагнер Apple
Yes, so
Motor
let's
остается
compare the
практически
rocket
без
with an
изменений.
airplane,
Плюс
so the
отражает
launch
и
control
увеличивает
is a
запас
bit like
топлива.
the
Третья
cockpit.
ступень Zephyr 9
The
остается
teams here are
прежней.
in charge of
Ракеты
preparing
Vega
the rocket
запускаются
and
со стартовой
checking it,
площадки и в
and they
Гвианском
monitor
космическом
all
центре.
these
Первый
final
полет Vega C состоялся
before
13
launch,
июля
and of course
2022 года,
after
когда
launch
успешно
the
вывели
rocket
на
goes
орбиту
on
спутник
autopilot. There is
AEISS-HR
two
и
teams,
6 других
one
спутников.
operational
Однако при втором
teams,
запуске 21 декабря 2022
running
года
the
произошла
different
поломка второй
operations
ступени,
and procedures, and
что
one
привело к
technical
потере
activities
двух
team
спутников при
checking that
AEISS-HR,
everything goes
предназначенных
well.
для получения изображений Земли.
All watching eagerly there and monitoring events now in the countdown. We have another room at Colleferro, which is just south of Rome in Europe.
Yes, these are the teams from Avio, the technical authority who manufactures the rocket. So
Также
they are
Vega
checking
C
from
имеет
Italy
новый
the
обтекатель
launcher
диаметром
behavior,
3
they are
метра и выстойчивый
analyzing
более
the
9
data, and
метров, что
people
обеспечивает почти
from
вдвое
different
больший
teams such
объем
as
пореза
propulsion,
нагрузки, чем оригинальный
structure,
Vega,
control and
который
so on,
обтекатель имеет
are
диаметр
available
2,6
and ready
метра и
to
высоту
jump in support
7,8 метров.
in case of need.
Always good to have as many people as possible
Если
ready to
брать
jump
по
in,
среднему
as you
таймлайну
say.
запуска, то
And
первая
we're coming
спина
up now
работает
to
142
2
секунды и
minutes to
достигает
launch. Vega
260
standing tall there
километров
on
и
her
скоростью
pad.
1,8 километра
You
в
can see the
секунду. Вторая
lightning
спина
towers, the
достигает
umbilical course. Talk us
121
through what we're
километра и
looking at.
скоростью
Yes, so
4,5
we can see now the
километра в
launcher
секунду.
ready on its launch table. You can see
На
here
245 секундах
the
после
fairing
запуска.
on top of the launcher. So
254 секунды после
there is
запуска
still
наносится 26
electrical
километров
and
сброса
ventilation
обтекателя.
links,
Третья ступень работает до 417
umbilicals,
секунды и
yes,
высоты
for
190
electrical
километров
checks
и
and
скоростью
ventilation
уже
in order to
7,5
ensure
километров в
the
секунду.
best
Ну и далее
condition
зажигание
inside
уже
the fairing cavity
четвертой
for
ступени.
our passenger
Там
tonight,
сколько
KOMPSAT-7.
нужно иметь
So
для
everything goes
вывода
well,
аппарата на
and
орбиту.
we are ready, fully ready for liftoff.
Everything is green, and as you say, KOMPSAT-7 up there in its first-class compartment, waiting to lift off with some nice air conditioning, keeping nice and cool. And you can see on the right-hand side, all the status panels are green. The various different systems sending their status here to these.
À tous de DDO. Attention pour moins 1 minute. Top H0, moins 1 minute.
И у нас
We are
остается
1
менее
minute to
минуты до
launch.
запуска.
We
Я
are
напоминаю,
live
что мы
at the
смотрим прямую
European
трансляцию запуска
spaceport in
ракеты
French
Vega
Guyana,
C
getting ready to orbit
с космическим
KOMPSAT-7
аппаратом
for the Korea
KOMPSAT-7.
Aerospace Research Institute, KARI. Good luck, everyone.
À tous de DDO. Attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Allumage P120, décollage. Le pilotage est calme, la propulsion est nominale. Acquisition de la télémesure par la station de Saint-Jean-du-Maroni.
Индия запуск ракеты Vega с космическим аппаратом KOMPSAT-7 со стартовой площадки ИВЛ в Космическом центре во Французской Гвиане.
KOMPSAT-7
И далее мы ожидаем разделения первой и второй ступени,
pushing itself against the gravity
который
of
будет
our
примерно,
planet
как уже
into the
я говорил,
equatorial
на
skies over the
142
Guyana
секунде
Space
после
Center.
запуска,
We
32
are heading out
минутах и
north
22
over
секундах.
the Atlantic. Look at that. Beautiful clear skies here with some fluffy clouds.
Обожаю трансляцию Arirang Space, как
He's telling
обычно,
us that
телеметрии,
everything is
вообще
going
ничего
according
нету.
to plan.
Спасибо, что хотя бы
And
ведете
didn't you see how
отчет времени
quickly
от
the
начала
rocket lifted
запуска.
off into the sky?
Yes, yes, very quickly. That's due to the type of the propulsion used by the launcher. So the first three stages burn solid propellant, and that gives a lot of power, and the launcher needs that power to tear itself from away from Earth.
Indeed, and that's the job of the first three stages, to tear us away from gravity, which is pulling us back down. Everything's going well, he's telling us. And right now we are burning, that's the engine that you can see is actually the P20 engine. It's the engine on the first stage. It's very powerful, isn't it?
Yes, P120, so very powerful first stage, thrust at liftoff of 4,300 kilonewton. It's delivering the punch of approximately 440 tons of force, so that's a lot of energy packed into a single solid rocket motor.
Fantastic images there of the P120 burning. The next event will be the switching off of that engine. That's coming up in a few seconds' time. And we can see it there. And we have confirmation from the range operations manager that the P120 has been separated, and we've switched on the engine of the Z40. Everything is going well, so we don't need that anymore, so we can jettison it. And we are shedding weight. We are now burning the Z40, the second stage, Vincent.
Yes, the second stage called Zefiro 40, Z for Zefiro, Z40, Italian, yes, for a type of wind.
You can see on the left-hand side are the events that will be coming up during the launch, and the blue line, if you like, at the bottom is us flying into space, and he's telling us that everything is going normally. And on the bottom right-hand side of your screen is the altitude, distance from the pad, and our speed in kilometers per second. Good shot of the fairing there, protecting our satellite.
Yes, fairing on top of the launcher, so it has different jobs. So it's protecting the spacecraft against the acoustic vibration at liftoff. It's also protecting against friction when the launcher flies through the dense part of the atmosphere, and that aerodynamic friction generates significant environment, for instance vibrations, of course, and heat for the spacecraft. And once we exceed the atmosphere, this aerodynamic loads reduce, so we can jettison the fairing, and the principle is to avoid dragging mass that is no longer useful for the launcher mission.
Indeed, that's the name of the game, to jettison every section of the rocket as we fly, as we no longer need it. Coming up now on our next big moment, switching off of the Z40, separating the Z40.
Allumage du Z9. Tous les paramètres à bord sont normaux.
And he's confirmed we've switched the engine on the Z9, everything's going normally. And we have separated the fairing. You can see it there in the animation, falling away in two halves. We don't need it anymore because we've crossed the border with space, so we are outside the dense part of the atmosphere, and we don't really need it, have to worry about friction. You can see our satellite for the first time, that's all.
Yeah, the satellite for the first time on top of the launcher, secured on top, on the adapter with a specific metal belt called the clamp band.
And quickly, just to explain here, on the top right-hand side of your screen, you can see the green line is the trajectory.
Yes, the trajectory. So in green, and in the yellow curve give us a real-time trajectory, so we can see that
также на 9 декабря запланировано возвращение биолетированного космического корабля «Союз МС-27».
We've started something that we call orbit optimized guidance attitude. What's that?
Yes, the onboard computer continually recalculates its position. This is to make sure that it's on the right course. And if it deviates, it corrects its position and comes back to the planned trajectory. So this is clear sequence, of course, with a very good onboard computer we have
Looking here at these CGI images, computer-generated images, or 3D, as they are sometimes known. It's an animation. It's an animation based on what's expected to unfold in space at this very moment. And he has just announced here the pushing of the Z9, poussée du Z9 in French. So yeah. And these computer-generated images are actually a simulation. It's not the actual telemetry, is it?
Yes, a simulation. So this is 3D animation that shows the predicted behavior of the launcher, not the real behavior coming from the telemetry. So it includes, of course, the trajectory in terms of velocity, altitude, ground track, the different stages separation, and but also all the launcher maneuvers.
Séparation du Z9.
And we have separation there.
Yes.
Of the Z9. That's confirmed.
Allumage du premier boost AVOM.
And we have the first switching on of the AVOM Plus upper stage engine confirmed. That's going to burn for about 9.5 minutes. And he's also confirmed that we've picked up the signal at the tracking station in Bermuda, which is a very beautiful island in the Caribbean. There you go, you can see where it is there. So Vega C checking in there and saying hello to the teams. 안녕하세요, Bermuda. So we are traveling. Have a look there on the right-hand side of your screen. Underneath the trajectory, our altitude, 247 kilometers high and climbing, our distance from the pad. And on the right-hand side, our speed, which is 7.5 kilometers per second.
Yes, already 7.5 kilometers per second, so very high speed, so it's equivalent to 27,000 kilometers per hour, so it's 30 times faster than a commercial aircraft, so very impressive speed.
Yeah, very, very fast.
Le pilotage est calme, la propulsion est nominale.
All's going well. The piloting and propulsion are nominal. So the main propulsion phase is now over. We've got away from Earth. We have started the next phase of our journey. The AVOM Plus upper stage has taken the wheel, and it has a very important job, because not only does it have to take its passenger to its drop-off point in space, but it then has to deliver it.
Yes, so we need to take KOMPSAT-7 to its orbit, so 576 kilometers above Earth, and to do that, we fire the AVOM Plus engine twice. This first time takes us to an intermediate orbit, and then later the second time will take us to what we call the injection orbit. That's the orbit where we will inject the satellite into space. And after that, KOMPSAT-7 will be able to start its new life and its important mission and tasks.
Indeed it will. And it needs to be on what we call a sun-synchronous orbit. That is a special type of orbit, north to south, nearly over the poles?
Yes, so it means the spacecraft fly over the same zone of the Earth at the same local time every day. So every time you pass over that zone, you're seeing it in the same light conditions. It means we can see the same zone in the same light day after day. So we can see how it changes over time. This is very useful for such missions, such as observing Earth and monitoring the weather.
Indeed, because these are the kinds of missions that need that constant and that continuity over time. So as we said, we are flying north. We've we're being tracked at the moment over the Caribbean. We'll be heading up over to the east coast of Africa, back over the North Pole and back down over Southeast Asia. And we are, of course, tracking our rocket using telemetry. We've got ground stations along the flight path. I mean, basically, the avian upper stage is talking to us, isn't it? It's communicating.
Indeed. The rocket sends a signal to the ground station as it flies over. They have a big dish to capture that signal, so a big antenna. That's how we know what's happening on board the rocket, and it allows us to track the flight in real time.
Indeed, we can see there, that's the Gatineau tracking station. That's in Canada. And the tracking stations actually send, and that's confirmed there, they send the data here to a hillside just outside the spaceport, the Guyana Space Center, and inside these teams are the quick look telemetry teams. Very important job. Yeah,
they are receiving those real-time data from the launcher and analyzing them. So data includes the status of the engine, the trajectory, the flight control. So they compare the live data from the rocket to what has been predicted. This allows them to continuously analyze the launcher behavior and confirm that it is as expected. It's a bit like the doctor checking the health to verify that everything is fine on board. So the team in charge is located in Gallio on La Montagne des Pères, 20 kilometers from the launch pad.
La Montagne des Pères, the mountain of the fathers. We saw it back there. It's very pretty, actually. It's very beautiful. So those teams in the Quick Look telemetry building, they are actually on an internal comms loop, and they're passing the information to the range operations manager here in Mission Control. We can see him there, and he then announces confirmation of all those major events to everybody here at the spaceport, because as you can imagine, it's a big place. So everyone across the range is listening in to his announcements. Vincent, we often talk, don't we, when we're talking about tracking stations, and we talk about a rocket going in and out of visibility of a tracking station. We talk about visibility, but actually the stations, they're not actually seeing the rocket, are they? Because obviously it's deep in space. We can't see it with our own eyes. But they are sensing it, right?
Yes, Katie. When we talk about the visibility of a rocket, we are talking about how the ground stations detect and receive the signals sent by the launcher. These signals contain information related to the position, the velocity, the onboard environment, and so on. This allows us to track the accuracy of its trajectory and monitor that it's behaving as planned.
And a key factor, of course, in rocket visibility is an uninterrupted line of sight.
Yes, so the antennas at the tracking station need a line of sight to the rocket, which is unobstructed. So that's because the Earth is curved. So the rocket becomes visible only when it comes above the horizon of the station. We call this the visibility cone. So let's imagine an ice cream cone. The narrow point is on the ground and the widest part is in space. So when the rocket flies into the widest part of the cone, the station can detect it.
It's actually a little bit wider, isn't it, than an ice cream cone? It's a great analogy. The next event will be the switching off of the upper stage engine, the Avon Plus engine. That's due in a couple of minutes' time. But the engine can switch on and off a number of different times during the flight. How does it know when to do it, when to switch on and off?
Well, the Avon upper stage has a brain. It's the onboard computer, so it contains the avionics, the guidance system, and an inertia measurement unit, which tells the computer its position, its speed, and orientation. So, of course, we plan the mission well in advance on the basis of predictions and mission analysis. We program all that information into the flight software. There are sensors on the upper stage. They feed real-time information to the computer about how far it has traveled and its position in space. And when the computer detects that the upper stage is on the right orbit, it sends the command to switch the engine on or off.
He's the range operations manager telling us everything's going normally. So that information that you talked about there, the inertial measurement unit, is picking up and sensing that, of course, then is all sent down on the signal that we were talking about, the telemetry signal. That goes down to the tracking stations. It then is relayed back here to the Guyana Space Center, to the Quick Look telemetry team who we saw there earlier. And of course that then allows us to have all this information on the right-hand side of your screen, which is the real-time telemetry data. So we can see we're 354 kilometers above Earth and our speed 7.78 kilometers per second. Coming up now to the switching off of the Avon Plus upper stage. There we go.
И есть выключение, первое выключение двигателя второй, то есть четвертой, ступени ракеты Vega с миссией KOMPSAT-7. Я напоминаю то, что вы продолжаете смотреть прямую трансляцию запуска ракеты Vega C с миссией KOMPSAT-7. И далее мы ожидаем второе зажигание двигателя четвертой ступени. Сейчас мы ставим 361 километр. Скорость 7,79 километров в секунду. Расстояние от места старта 6000 километров.
So we are now in what we call a ballistic phase. That means... There we go. That means we're travelling without propulsion. He's just told us that we've reached our orbit at the end of the first phase. And now you can see actually what's happening here. We're doing some manoeuvres, aren't we? Why are we switching the engine off right now?
Well, we are on the right orbit, so we are on the intermediate orbit, which is an elliptical orbit, so with an oval shape. So if there is no other boost, we will come back to the Earth with an uncontrolled re-entry. So that's why we need a second burn at what we call the apogee, so the furthest point on the orbit to circularize the orbit.
Indeed, and if you look at the screen, you can see actually that we are now in a position vis-a-vis the sun. Kind of looks like we're pointing downwards, but actually what we're doing is we're getting ready now to start rotating as if on a spit. It's called the barbecue phase.
Yes, so at the beginning, we need first to have a certain orientation with respect to the sun, and then the launcher, as you will see, is spinned very slowly along its longitudinal axis in order to ensure the optimization of the thermal control on board. It is what we call the barbecue mode, as you said. It prevents overheating during this long coast phase, and at the end we tilt again the launcher in the good orientation, and then there will be the reignition of the upper stage engine.
Indeed, and that's all coming up. You can imagine that it's very cold when you're facing space, and it's very hot when you're facing the sun, so rotating like that is the perfect way to keep the temperatures nice and even. We're going to be coming back to you. We're going to take a short break now. We'll be back in about 16 minutes or so. And just to quickly let you know that we have a completely normal and planned gap between telemetry signals, so we're going out of the range of Gatineau, we've just heard it there, and we'll be going into the range of the next tracking station, Jeju. So we are taking a break. We're going to be back at 2:56 here in Kourou. That is 6:56 in the evening in Paris and 2:56 in the morning in Seoul. We'll see you back here then.
Attendu de la télémesure. Acquisition de la télémesure par la station de Jeju. La trajectoire est nominale, tous les paramètres à bord sont normaux. Tous les paramètres à bord sont normaux.
Welcome back to our YouTube live road to space. I'm Katie Haswell. Vincent Bourdelle is still with us from Arianespace. Thanks for being with us.
Good to be here, Katie.
You've been watching there those wonderful images of the launch of KOMPSAT-7 on board the Vega C rocket, lifting off from the pad here at the Guyana Space Center. Talk us through what's been happening. That was about 37 minutes ago, 36 and a half, nearly 37 minutes ago.
So the Vega mission started today with the ascent of the P120, the Zefiro 40, and then the Zefiro 9. So then the Avum Plus upper stage took the lead with a first boost for nearly 10 minutes to reach the intermediate orbit. And now we are in a ballistic phase that takes us over the North Pole and then down to South Korea. And in a few minutes, the Avum Plus will reignite its engine to circularize the orbit and to reach the final orbit where KOMPSAT-7 will be delivered.
And right now, during the break, we had confirmation from the range operations manager that we have gone into the range of the tracking station at Jeju Island, which is off the coast of South Korea. It's very popular with tourists. And I think it's very easy to see why, because it's beautiful. It's known for its volcanic landscapes and very lush vegetation, wonderful climate. And it's actually home to South Korea's highest peak, a dormant volcano called Halasan. And you can just see there in the distance the little island of Udo off the coast with its white sandy beaches. It's famous for volcanic landscapes, dramatic waterfalls, lush rainforest, great for hiking. And there are plenty of food delicacies, including the sweet tangerine, which it's famous for. They grow all over the island. These stone guardians are the Dol Halobang, symbols of protection and fertility, and they're just one of several UNESCO World Heritage Sites preserving the island's history. And these are the Henyo women, continuing a centuries-old tradition of diving for seafood whilst holding their breath under the waves. That's very impressive because they don't use oxygen tanks at all. So I think you can see there from every angle that Jeju Island offers a mix of stunning natural landscapes and cultural experiences. It's beautiful. It's a great place for a tracking station.
Yes, apparently a good time to visit is in the spring, so the cherry blossom. And the weather is lovely. So another good time is the winter. You can hike on the mountain in the snow.
Sounds lovely. Let's get back to our flight, back to our journey. We are 39 minutes and 17 seconds in. The next event will be to restart the engine, but if you remember before the break, we orientated for the barbecue phase. Before we can restart our engine, we need to orientate back into the right back on track, don't we?
Yes, so it needs to reorient to the precise pitch, yaw and roll angles, which are needed for the next burn. So it is very important to continue the journey in the right direction.
Range Operations Manager telling us there that everything is going normally and according to plan. And you can see just off the coast of South Korea, there is Jeju Island. We are literally flying over it right now, and you can see the light from the town and the dark color, I guess, is
прямую трансляцию запуска ракеты Vega C с миссией KOMPSAT-7, и сейчас у нас будет второе зажигание двигателя четвертой ступени. И здесь зажигание двигателя четвертой ступени для уже выхода на окончательную орбиту и отделения аппарата KOMPSAT-7. Я напоминаю, что запуск был произведен сегодня, 1 декабря, в 17:21 со стартовой площадки AEISS в Гвианском космическом центре во Французской Гвиане во Франции. KOMPSAT-7, либо же Arirang 7, то есть Korean Multi-Propulsion Satellite 7, Корейский финансовый спутник 7, это легкий спутник наблюдения Земли, разработанный Корейским институтом аэрокосмических исследований. KOMPSAT-7 это усовершенствованная модель KOMPSAT-3. Он разрабатывается с целью предоставления спутниковых изображений высокого разрешения для удовлетворения национальных потребностей. Космический аппарат разрабатывается с использованием корейских технологий под руководством корейских компаний. Корейские компании также участвуют в разработке полезной нагрузки, которые разрабатывает Кэрри для продвижения возможности отечественной спутниковой индустрии. KOMPSAT-7 будет оснащен космической камерой высокого разрешения Advanced Earth Imaging Sensor System with Sky Resolution, которая обладает разрешением 30 см то есть в панхроматическом режиме, 1,2 метра в цветном режиме и 4 метра в инфракрасном режиме. Отделение аппарата через примерно 45 минут после запуска. Производитель спутника Korea Aerospace Industries. Ее оператор — это Корейское аэрокосмическое управление. Запуск достаточно синхронной орбиты. Вес аппарата составляет 1710 кг. Это был 28-й запуск ракеты Vega, 3-й в этом году, а также 305-й запуск Европейского космического агентства и 6-й в этом году. И сейчас мы, собственно, ожидаем отключения двигателя четвертой ступени. Тем временем высота составляет 578 км, расстояние от места старта 16400 км, скорость 7,63
Our passenger today is on its high-speed train, getting off at the end of the line, its very own dedicated station. Now we need to deliver KOMPSAT-7 onto exactly the right orbit in the right orientation, and to do that the upper stage will be performing a set of maneuvers. So there we have cut-off of the AVM
début de la manœuvre d'orientation au profit de KOMPSAT-7.
Plus upper stage and the beginning of the orientation maneuver for KOMPSAT-7. What does that mean?
Yes, so we are now on the separation orbit. So before we can separate the spacecraft, the launcher needs to put it in exactly the right position. So it needs.
И есть второе отключение двигателя четвертой ступени ракеты Vega C и на отметке 43 минуты 54 секунды через 40 секунд, собственно, мы ожидаем отделения самого космического аппарата KOMPSAT-7 от четвертой ступени. Кстати, сейчас
And we're going to eject it with a set of springs.
Yes, so the spacecraft is secure on top of the upper stage with a specific metallic belt called clamp band. So as soon as it is released, in fact, we have the activation of simple springs that enable the separation.
Flying again, there you can see another shot of Jeju Island. And we have confirmation there of separation of KOMPSAT-7 right over Jeju Island.
И есть соединение космического аппарата KOMPSAT-7 от
South Korea has a new
четвертой ступени ракеты
satellite.
Vega
You can
C.
see it's moving away gently
Успешный.
from the
И
mothership.
на этом прямая трансляция, собственно, буду заканчивать. Всем спасибо
So that's
за просмотр.
great news.
Всем
Huge congratulations to everybody and to all the teams